Hello everyone, welcome back to this YouTube channel, IBwontcrushyou, and today we are dealing with non-right angled trigonometry from the chapter Geometry and Trigonometry, and as always we will go through some problems just to make sure you understand this topic as well as you can. Problem 1. Point P lies on the unit circle and corresponds to an angle of theta equals 150 degrees. A. Write down the coordinates of point P. So in here we have to remember that we are dealing with the unit circle. The first coordinate is always cosinus of our angle, and the second coordinate, so our y coordinate, is sinus also of the same angle. So our coordinates of point P are cosinus 150 degrees and sinus 150 degrees, and we have to calculate them on our GDC. So these coordinates are minus square root of 3 over 2 and 1 over 2. So that's our final answer for this point A. Point B, determine sinus 150 degrees, cosinus 150 degrees, and tangents 150 degrees. So basically we have answers for the sinus and cosinus, so we only have to calculate our tangents. However, we can observe that tangents is always sinus over cosinus. So we can calculate it in this way. So sinus 150 is of course 1 over 2. Cosinus 150 is minus square root of 3 over 2. And tangents of this angle is sinus over cosinus. So sinus over cosinus. So we can rewrite it as 1 over 2 times negative 2 over square root of 3, and this cancels out, so minus 1 over square root of 3. And here we have to multiply our answer by square root of 3 over square root of 3, so this is 1. However, we cannot have square root or any root of something in our denominator, so we have to multiply by our denominator. So in numerator we have to have the square root, and in the denominator also the same value, so this is basically 1, and our final answer is minus square root of 3 over square root of 3 times square root of 3, so just 3. Of course we can calculate it immediately from the GDC, so the answer will be the same. However, it's worth remembering that tangents is basically sinus divided by cosinus. And C, explain geometrically why the signs of these values are as they are. So if we were to draw our coordinate system, our 150 will be in the second quadrant. So we can draw something like this. This is y-axis, this is x-axis, our first quadrant, second, third, and fourth. And here we have 150 degrees, and in here our x is less than 0, so the cosinus is negative, you have to remember it, and y is greater than 0, so sinus is positive. So this is what we already calculated. So our cosinus is negative and sinus is positive, and you have to remember that. And tangents also in the second quadrant is negative, and we can also know it from that tangents is sinus over cosinus. So sinus is positive, cosinus is negative, so positive divided by negative is negative, so as we expected. So we can write something like this. Problem 2. In triangle ABC, angle A equals 40 degrees, angle B equals 75 degrees, side AC is 12 centimeters. A, find the length of side AB. So firstly, let's calculate angle C. So we know that the sum of angles in the triangle is 180 degrees. So from this we subtract 40 degrees minus and also 75 degrees, and this is 65 degrees, and 65 degrees corresponds to our angle C. And now let's draw this triangle to see how it looks like. So this is our triangle, and we have to find the length of side AB, so this side. So we can use in here the sine rule. So x over angle that is opposite to it, of course sinus of this angle, so something like this, equals, and now we have to take side and the angle opposite to it that we know these both values, so 12 centimeters and 75 degrees, so 12 centimeters over sinus 75 degrees, and we can find it simply in solver. So x is 11.3 centimeters, and B, find the area of the triangle. So we can basically we have to use the formula for the area of triangle from the booklet, and it looks like this. Area equals 1 over 2 times A times B and times sinus C. So we can substitute our values, 1 over 2 times, and we have these sides, so 12 and 11.3, and C corresponds to angle between them, so times sinus 40 degrees, and this is equal to 43.6 centimeters squared. Problem 3. A ship sails from port A to port B a distance of 45 kilometers, then it continues from port B to port C a distance of 60 kilometers. The angle between the two courses is 115 degrees. A, find the distance from A to C. So firstly, let's draw our little diagram. So we're starting in point A, and let's draw it like this. So A in here, B in here, here distance of 45 kilometers, and here let's draw our second straight line. So here we have port C and distance of 60 kilometers, and the angle between the two courses is 115 degrees. So in here, and we have to find the distance from A to C, so let's draw a straight line from A to C. And this is our diagram. It looks like a triangle, so we can simply find it. And in here, we can use our cosine rule because we have two sides and the angle between them. this is the formula, and now we have to substitute our values. So a squared plus b squared, so doesn't matter which value we will take first. So maybe 45 squared plus 60 squared minus 2 times 45 times 60 and times cosinus of the angle between these sides, so cosinus 115 degrees, and we have to calculate the value of C. So C is 88.9 kilometers. B, find the area of triangle ABC, which can be interpreted as the area of the bay. So here we have to use our area triangle formula from the booklet. So it looks like this: 1/2 times A times B and times sinus C. So A equals 1/2 times 45 times 60 and times sinus of the angle between them, so 115 degrees, and we have to calculate it on our GDC. So the area is 1223.5 kilometers squared, and see if the ship had sailed directly from A to C, how many kilometers would it have saved. So this is the distance that ship traveled, and this is the distance that we found, so 88.9, and this is direct distance from A to C. So basically we have to add 45 and 60 and subtract 88.9, and this is 105 minus 88.9, so the final answer is 16.1 kilometers. Problem 4. A triangle plot of length PQR has the following measurements. PQ equals 120 meters, PR equals 85 meters, and the angle QPR equals 48 degrees. A farmer wants to build a circular water tank inside the triangle so that it touches all three sides that encircle. A. Find the length of side QR. So firstly, let's just draw our image. So a triangle and a circle. So this is our image, and now we have to calculate the length of side QR. So you can observe that this is this length, and we have this side, and the angle between them. So we can use cosine rule. So let's rewrite this cosine rule. It looks like this, and now we can substitute our values. So 120 squared plus 85 squared minus 2 times 120 times 85 and times cosinus 48 degrees. And now we have to calculate it. We can take the square root of everything and see. So QR is 89.3 and units meters. B. Calculate the area of the triangle. So in here we also use the formula from the booklet. So formula for the area of triangle. So area equals 1/2 times A times B and times sinus of the angle between them. So A is 1/2 times 120 times 85 times sinus 48, and we have to calculate it. So area is 3790.004 meters squared. C. Find the radius of the inscribed circle. So this point is a little bit difficult, however, we have to solve it anyway. So we have to observe that from the center of our circle, we can just divide our one triangle into three smaller. So we can do something like this. So connect the center with vertices, and you can observe that we have three smaller triangles, and each has the same height, and this is basically our R, so the radius of our inner circle. So this is height of each triangle. So and here we have our total area of the whole triangle. So this is the area of the whole triangle. So 3790.04. This is area of the whole triangle, and we know that this area is made of three areas of these smaller triangles. And now the area of the small triangle is, we know, 1/2 times base, so A, and plus, and times height, and in our case height is just R, radius. So now we can calculate basically the area of each small triangle. So we can denote this as 1, 2, and 3. So our first area of this triangle is 1/2 times 120 and times R. Second triangle, 1/2 times 89.3 times R, and third triangle, 1/2 times 85 times R. So we have area of each triangle, and we know that the total area is this, so 3790.04 equals. And now we have to just add these areas. So this is our equation, and we can find it simply on our GDC in window solver, and the answer, so radius, is 25.8, and here we have units, meters. So this is our final answer. And point E, easy one. If the farmer paints the circular tank with a special coating costing $35 per square meter, find the total cost. So firstly we have to calculate the area of circle. So area is pi times r squared, so pi times 25.8 squared, and we have to calculate it. So this is 2091.17, and of course meter squared, and the total cost will be our area times cost, so $35, so 2091.17 times 35, and A equals 73,190.94, and of course units dollars. And it was the last problem from this topic, non-right angled trigonometry. And if you found this video helpful and useful, please leave thumbs up, subscribe to my channel, and in case of any questions or any doubts, feel free to reach me out in the comments down below or via my mail that is as always in the description of the video. And in the description you have some information about a little contest. Yeah, and thank you for watching. Bye!